assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this problem, we want to boil 35 liters of water, and we need to know how much fuel, specifically C7H16, how much of that fuel we will need. And so the first thing we do is calculate the heat required. So that's just MC delta T. And so our M is going to be our 35 liters times 1,000 grams per liter in order to get that into grams. Then our specific heat of water, 4.184 joules per gram degrees Celsius. And then our delta T, which is 100 degrees Celsius minus 25 degrees Celsius. Since the boiling point of water is 100 and we start at 25. And then we'll divide this whole thing by 0.15 since our fuel is producing 15% efficiency, then we need to divide this by 0.15 in order to get the total Q. And so when we do this, our Q is equal to 73220000 joules or 73220 kilojoules. So this is our required heat. Now the next thing we need to do is determine the amount of heat that is generated from the reaction of our fuel. And so to do this, we write down the equations, the chemical equations that we know of. So 7C solid plus 8H2 gas forms C7H16 liquid. And we're given in the problem that the delta H for this is negative 224.4 kilojoules per mole. Then we can also take C solid plus O2 gas to form CO2 gas, and that has a delta H of formation of negative 393.5 kilojoules per mole. And then finally, we can take H2 gas plus 1/2 O2 gas and form H2O gas, which has a delta H of negative 241.82 kilojoules per mole. And so the three of these are simply delta H of formation of these. We are just devising them in this way so we can compare them and find a total equation, which I'll do now. And so we take the first equation and we flip it. We have C7H16 liquid forming 7C solid plus 8H2 gas. And so we flip the sign of our delta H to positive 224.4 kilojoules. Now we take our second equation and multiply it by 7 in order to get the 7C solids that we have in our previous equation. So 7C solid plus 7O2 gas forms 7CO2 gas. And that has a delta H of negative 2754.5 kilojoules. We just multiply it by 7. And then we take our third equation and multiply it by 8 in order to cancel out the 8 H2 gas that's over here. So we have 8 H2 gas plus 4 O2 gas forms 8 H2O gas. And that has a delta H of negative 1934.56 kilojoules. So now we can sum all these equations together. And so we end up with C7H16 liquid plus 11 O2 gas forms 7 CO2 gas plus 8 H2O gas. And then we sum our delta H's to get our new delta H to be negative 4464.66 kilojoules. And so now that we have that, we can take the heat required to heat up our water, 73220 kilojoules, and divide that by the heat per mole that we just found, 4464.6, one too many sixes, 4464.66 kilojoules per mole. And that'll give us moles of gas. And so we can take the molar mass of C7H16, 100.2019 grams per mole, and then divide that by the density, 0.78 grams per milliliter. And the density is given in the problem. And so that gives us that we will need 2106.80 milliliters or 2.1 liters of fuel. And that is our final answer.